in this today's videos we are going to solve the third question of the today contest, a weekly contest. So the question is partition arrays to minimize XOR, right? So this question is a little tricky and we should understand the concept behind how to solve and what are the approaches to solve this problem. So we are driving into a new problem, that is from the contest, today contest, and we'll solve this problem, right? So let's continue to understand this problem. So this problem is based on you can say very interesting topic, that is dynamic programming, and it sounds complex at first, but we will break it down in such a way that it will become easy for you, and I'll go through the intuition and then we'll do dry run the problem. So stay tuned and let's understand the problem step by step. Okay, so the question is saying that you are given an integer array and it is named as nums, and another variable k we have given. So what is our task? Our task is to partition this array nums into k non-empty subarrays. Means we will partition this array into subarrays, but the subarrays should not be empty. It should be, some elements should be there in k parts. So for each subarray we have to what? We have to compute the bitwise XOR of all its element, and then we have to return the minimum possible value of the maximum XOR among these k subarrays, right? Means we have to find the minimum possible value of the maximum XOR among these k subarrays. What is a subarray? Subarray is a contiguous non-empty sequence of elements within an array. Okay, and so the example we have given like this. Okay, so what we have given? We have given an array of nums, as you can see in this example, and we have given an integer k. It means we have given this array and we have to split this array into exactly two contiguous subarray. Then we have to compute the bitwise operation, right, on each subarray. Let's suppose if I will break it from here, we'll take 1 and 2 3. So one is one subarray and another is 2 3, right? So now we have to apply on this subarray 1 and 1 2 subarray bitwise XOR operation on each subarray, and will return the smallest possible value of the maximum XOR among these subarray. Understand? So we'll go through and understand how we have to do that, right? So what we have given? We have given the array we have given and nums we have given. We have to split in k times, right? Then understand what is XOR, right? So XOR is a bitwise operation, right? As you can see, if we'll do 2 XOR 3, we'll get 1. In binary, 2 is represented as 1 0, right? And it will and 1 1, right? So if we'll make it a bitwise operation, right, here we'll get what? 0 1. If we'll take 3 3, we'll get 0. If we'll get 1 2 3, we'll get 0, because first 1 and 2 will get 3, and then 3 and 3 will do 0, right? So we'll get 0. Understand? Like this we operate the XOR operation. Now understand, what does the partition into contiguous subarray mean? Means we have given the array we have given, right? Let's suppose we'll call it 1 2 3, right? And we have given k equal to 2, right? The partitions. So there is two valid partitions is possible. For, let's suppose for the first partition, I'll take the first subarray, we'll call 1, and another will take 2 3. Another subarray can be 1 2 and 3, right? But if you'll take 1 3 and separate 2, so this is not valid, because after 1 it should 2 should be there, but it is coming 3, means we are skipping the 2 here, and that is why it is invalid. So the possible and valid subarray or partitioning is this way we have to do. Only possible partitions are these two are there, right? So we can do the partition like this. Okay, I hope you understand, right? So the example 1, it was saying 1 2 3 k equal to 2, So we need to split into two parts, because k we have given what, how many, 2 we have given, k equal to 2, means we have to split this array into two parts, right? So if we'll try those options that we have seen, right? So the first step, we can partition 1, and another subarray we can take 2 3, means first partition of the sub array will become a subarray 1, and another subarray will become what, 2 3. So if we will apply XOR on this subarray, so XOR of 1 and XOR of 2 3, right, it will become what, 1. So we have to take, means XOR is coming 1, it is coming 1, right? Which is the max? So max XOR we have to find, right? So you can say 1 1, we'll get 1 here. In another one, we'll take 2 3 and 3. So XOR of 1 2 means these two elements will get what, let's call it 3. Another we have 3. So max if we want to take, what will come, 3. It means therefore the minimum possible max XOR is 1, right here, and so the answer is 1. I hope you understand the example, correct? Similarly, we have example 2, example 3. You can pause and you can see its answer. Okay, what is our goal, right? Just understand what is our goal. So as we know, so the first thing we have to understand what the question is asking to us, means what we need to do, means we need to split the array into k pieces, and then we have to compute the XOR of each pieces, right, each piece, and among all the possible ways to split, means we have to find the one where the maximum XOR is as small as possible. Understand? Then we'll approaches, we have to understand what are the approaches is possible for this problem, right? Before solving, what we should understand, the intuition. So how do we solve this problem, right? We know the brute force will be slow. So there are many ways to partition the array. So there is a concept, dynamic programming, right? And the dynamic programming that is called DP also, right? So we'll use a DP function that will do our job, right? And so we should understand before going to the so to solve this problem, right, I will use in this video, we'll go through the dynamic programming, because that is optimal solutions, right? But I'll show you the couple of approaches are there that you can use to solve in this video. Okay, so first of all, understand the approaches to solve this problem, right? So we are given an integer nums and integer k, and we need to partition the number into k non-empty continuous subarray, means we want to compute the XOR of each subarray, and we have to minimize the maximum XOR among them, right? So what are the key observations? So key observations are like continuous subarray are required, means only partition the position matters, not the combination or permutations. Understand? Then bitwise XOR is a monotonic or additive, right, unlike a sum. So standard greedy doesn't work here. Okay, so we'll minimize the maximum XOR across the k partitions, right? Means first of all, continuous subarray we have required, then we have to operate bitwise XOR, and then we have to find the minimizing the maximum XOR, right, across the k partitions. So the very first approach is brute force approach, that you will get a TLE, right, time complexity you will get, and then you will get this error and the code will not get accepted, right? Because if you will try all the possible ways to partition nums into exactly k continuous sub arrays, right, then you will compute the XOR for each subarray, and you will track the maximum for each partition configuration, and you will return the minimum among all such max XOR values, right? So you can do that, but we have to try all the possible ways, right? And in that case, the complexity could be in exponentially, right? That can increase if n is more than 20, right? So that is not viable, right? And so the brute force approach for backtracking, right, is not a good approach to do that. Okay, there is another approach, that is a top-down dynamic programming with memoization, that is very efficient up to n equal to less than equal to 250, right? Let's suppose we will take a DP function. This will be our state. You know, if you have basic understanding of dynamic programming, so you know that there is a state right? You can take a basic what you call the base case. After that there is a state, so there will be a state of the DP where you can find the, you can pass the arguments that is required. Let's suppose we'll call I and k. So you can find the mean and max XOR when partitioning the num at I. So when we'll move to the nums at I, we'll take how many partitions we need, right? So you can take that, right? At each index, how many partition is possible, that you can get from the states, right? You can get the all the subarrays at this index for this number of partitions. So the transitions for every possible, let's suppose call j, is from I to n minus 1. So the partitions will be on I to j, and we will make it a XOR it, right? Then we recurse on the DP j plus 1 k minus 1, correct? So in this case, because we will traverse for all the possible j, in that case we will go for n square into k, means number of partitions, right? And space will come n into k because we will use the memorization table, right? So this approach is best approach for the given constraint, right? Another approach we have is binary search, and we can also use some feasibility check that is called greedy, and this is called advanced idea. Okay, so I'll talk about this in another video, but we'll go through in detail. Okay, then we have another approach is try based on XOR. So this is not helpful actually. XOR related often on the tree is not beneficial, right? And so people not trying to use this in the practice, right? So try isn't suitable, but you can use it, you can solve this problem by this, right? If you want, let me know in the comment box. I'll create another video, you can see that. Okay, now understand, choose the best approach, right? How we are going to choose the best approach. If you are good at the dynamic programming, right, and binary search, right, and trace, so there is possibility that you know everything, right, once you have the command over the DSA. So the approach that is optimal is top down approach you can use, or bottom up, right? So top down is best because it gives you the recursion way, right? Recursive way, we will memorize that table, right? And this is a best practical solution, you can say, right? Only the bottom up is little slightly more complex, and so we will not use this one, we will go for the top down approach. Okay, so what is the idea? Idea is we want to minimize the maximum XOR among the k partitions, and the brute force way is to try every way to split the array into k parts, and we'll keep track of the maximum XOR for each configuration. So out of all such configuration, we'll return the minimum of those maximum, you can say, because the length is, the constraint we have given is less than equal to 250, and k is also less than 250, less than equal to. So we can apply the dynamic programming with the bit masking or memorization, right? So either you want to use the bit masking or memorization. We'll use the memorization here. So let's continue with the top down approach with memorization. So first of all, you will define dp I and k, means we have to say that this state will minimize the possible max XOR we can get from the nums at I by splitting into k subarrays, right? So at each step we'll try all the possible j, where j ranges from I to n minus 1, and we'll consider the nums at I to j as a one subarray, and recursively we'll find the another subarray using the next step j plus 1 k minus 1, right? And we'll do recursively this step until we find it, until we will complete all the k number of partitions. So for every valid partitions we'll do that, right? And so the function we will use the, let's suppose res equal to mean res max current XOR dp j plus 1 and k minus 1, right? We'll understand in the deep. So the memorization DFS we will use, let's suppose this is our solution class, we'll define the memo table, right, memorization table, and this is n that we will initialize here. So n equal to nums dot length we will use, and we'll initialize the n, and then similarly we'll initialize the memo table, right? And this is will store the calculated subarrays, right? So we'll have n and k plus 1 will store the all the values here. Let's suppose we'll have for we'll take a for loop, right? We'll get the row, and for each row we'll get from here, and we'll fill with -1. Then we'll start the DFS from what? Here we'll pass the array 0 and k. So initial step, or you can say that we will use is 0 and k. Okay, so 0 is nothing but our I, and k is the partition, number of partitions we required. So these are the base cases that we required, right? So let's suppose we don't need to do partition. It means k is equal to 0 and I equal to n, right? Means we are at last. If this condition match, we will return 0. If k is 0, I equal to n, right? It means return the max value. If memo at I and a k is not equal to -1, means return the calculator value, right? We will return. Then we have res, you will do what? Integer of max value, right? And you will find the minimum, right? So you have to take the max value here, infinite value. So you will get math.min, and you will have the res and the math.max. You will find the XOR value and the next value, right? You can get it here. How will get the next, right? You will get from DFS nums j+1 k-1, right? And you know the XOR operations, how will operate. So all this loop will start from I to up to n, right? So for each index you will get the possible subarrays. Okay, so let's write on the code so you'll understand. Okay, so let's understand. We have given 1, 2 and 3, k equal to 2, means we have to do partitions. So partitions for the first for this case is possible is 1, 2, 3. So the XOR of this will become what? 1, and for 2 and 3 will become 1, right? So if we'll take the max between 1 and 1, what will come? 1. So this is our optimal. Let's suppose we'll partition at here. It means we'll get 1, 2 and 3. So in this and this you will get the XOR is 3 and 3. So max is 3, right? So we have to find the minimum between this and this. What is the minimum one? This one. So we'll get the final is at 1, right? So in this case, let's suppose we'll start the DP at what? 0 and 2. Because we choose this one, let's suppose. So DP will start from 0, index 0 itself, and 2 is the k, right? So we have to split from index 0 into 2 parts, right? So we'll try the split at index 0, and we'll have the first part is 1, and we'll getting the XOR, and that is why we are getting 1, right? And then we have remaining become what? 1, 1, right? Let's suppose we'll call it at here, and the k is get updated, means I plus 1, it will become I plus 1. We'll call it here. You see here, this was j plus 1. So previously j was at 0, right? Now j is 1 and k will become -1, right? And so we have to take what? DP now become what? From 0, it was 0. Now j plus 1 means 1, and k minus 2 is 1. Understand? So you will get DP of 1, 1, and you will get the XOR of 2 and 3, and you will get the value what? 1 here. So XOR of 2, 3 is 1. Understood? Then you have to find the max between this and this. You know the 1, because we have seen 1, it was coming 1. Similarly, we'll try the second split at 1, because the first split we have checked. Now we will check the second split, right? So second split will become from here, right? In this case, the first part is 1, 2, right? You can see 1, 2. So what is the max is coming? 3, right? For we are getting 3. Remaining is 2, 1. So we have taken 1, 2, right? Now let's suppose the remaining DP will become what? Plus 1. So become 2. Then it will become what? 1. Remaining is 1, because the first we have already seen right here. So in this case we'll get what? 3, right? So max we will find, we'll get 3, 3. Now take the minimum of all. What is the minimum of all? So at DP at 0, 2, we are getting 1. So this is our minimum RES, right? So this is our RES that we will update, right? The minimum, we have to find the minimum, right? So you will get the next, what is the max between this, that one, and we have to find the minimum of this. The minimum we have already updated for the first time, right? When we was here, we have already updated the minimum, right? So already RES have this value, right? And so next time it will come, so it will not take minimum, it will take which one the minimum is, that we will update here. Okay, now do the deep dive. Okay, so our goal is to split 1, 2, 3 into 2 continuous subarray, so that the minimum of each subarray XOR is as small as possible. It means DP at I and k, if we'll take, means the minimum possible max XOR from I, we have to split into k subarrays, right? So let's suppose in the very first step 0, we have to initialize everything, right? It means n equal to 3, the length of nums memo is I and k will define but -1. If you see the code, what we are trying to do here, we are defining what this memo and n, right? You have initialized this memo, right? As you can see, we have the number of element you will get, and the memo you will initialize n and k plus 1, right? It means when was we have initialized n, we will get what nums is 3, and memo is I and k we will initialize is what -1. Means initially nothing is computed, will define -1. So all these array, this is a memo table, okay? So all these array will become -1 -1 -1, right? So I is 0 1 and 2, k is initially 0, then 1, then 2, okay? So when you write the dp and you are writing n and k plus 1, right? So you have to fill this. How you will fill this? For you will make a for loop and you will take the dp at each row. Each row is at when I is 0, you will get this array, then you will get this array. Like this you will get each row, right? And you have to fill with what -1. So you will fill it and you will see like this, right? You cannot see, but visually if you understand, it will feel like this, right? All this become -1 -1, all the row will get filled, right? Now once this is initialized, means this job is done, we will start dp at 0 2. So let's understand when how we are starting the dp at 0. You can see, right? We are taking dfs, right? And we are passing what nums 0 and k. Like that we have to initialize the dp. So we will initialize dp 0 and 2, correct? Now that was the initialization step, that is 0 step. Now this is step 1. So from here the everything works, right? Let's suppose you have initialized everything. Now the very first step start. So dp at 0 and 2. 0 means the from where the I will start, and k is 2, correct? So we are computing the minimum XOR. How will do the minimum XOR? Let's suppose the min XOR is nums and k, we have function. So it internally it will compute what dp at 0 2, right? Means we have to find this, means we have to partition at what index 0, and you have to do how many partitions you have to need to do? 2 partitions you have to do, right? It means in this step we will start recursion using the dp, and we will populate the dp array, right? So we want to split the array into 2 parts. That is why I'm saying how many parts we have to do? The 2 parts. It means we want to split these nums into what 1 2 3 we have given into 2 parts, right? So we'll try all the possible j to split the first subarray. Let's call it subarray 1, and we'll write what is 1. Subarray at 1 between 1, the subarray 1 is nothing but 1, means from 0 to 0. It is called XOR, and we'll get the 1 that we have already seen, right? Now we'll call what plus 1. So this I will become plus 1 and this j will become -1, right? As you can see here, right? We are doing j plus 1, k minus 1. When I was 0, we have already calculated everything, right? So the current XOR is what 1 we have got, right? Next time when we will update it, so it will I will become plus 1, means j plus 1 and k minus 1, right? Because j start from 0, and so the j will start from j 0, then it will become what j plus 1, right? So it will dp become 1 1, correct? So from index 1 to end we'll make a part, right? And we'll say, means let's suppose we'll call it a 0 1 and 2, means we will start from here and we'll go till here, correct? So we'll start at the index here and we'll go till here and we'll make a part, right? One part we can say that, okay? Remaining part we can say also. It means we will compute the step 2, we'll find the dp11, right? We will find the dp, that is the dface. So you can call it and you will get what remaining is 2 3, correct? Now since k equal to 1, now you can take the entire part as a 1 subarray, right? So the first part you have taken 1, you can take the entire part as 1 subarray. So the first subarray is this, another subarray will become the rest of the part, because k equal to what now remaining is 1 because k minus 1 we have done, right? So k we have started from 2, but now we have done minus 1, so we'll get k equal to 1, and in this case the remaining is one subarray. Okay, so this will take one subarray. Okay, you can go through the DFS method, right, entirely from here, I, j, k, right, like that. Okay, now we have to return 1 to the parent, right? So you have this value, right, and you are updating our res, so you are putting all this value, will put here, you will get the mean value, you will keep updating here. Okay, now it is saying back in the dp02, right, max is 1, and we are putting the value here, right? So we'll take the 1, dp11, you will get max of 11, you will get 1. So the current mean is 1, so we'll store memo at 11 is nothing but 1. Okay, like that means first of all we will partitions each of the time, then you will find what the JOR we will find, right? You will find the JOR is nothing but what 1, because we have taken the JOR nums at j, right? JOR you will get, then the next you will get, right? Next you will get what dp11, right? Now this value will get calculated, and the previous value we have, which one is max, now we will get at res. Okay, so initially the res we are taking, that is why max value, so that whatever the value will come from here, it will be minimum from here. So the calculated value for the first time, it will come on the res, right? So you will have the now memo at 11 is 1, so we'll update our here value. Let's call it when we are trying j equal to 1, right? Let's call it subarray 1, and that is 1 2 this time, right? When we are trying j equal to 1, we have tried j 0. Let now try j at 1, right? So the j at 1 is subarray is 1 2. So in this if we will do the JOR, we'll get what 3 here, right? If we'll apply on this one, now you will call what dp 2 and 1, correct? Because j we have to go what, it was 1, so j plus 1 is 2, and k was what 2, now it become minus 1, so it will become 1. So now you have to call dp21, correct? But in this step, if you call it, you will see you have to update the value, right? So previously it was 1 when k equal to, so you have updated 3 here, and previous was what, it 1 when we have started, it was at I equal to 1, you will get the 1, when I equal to 2, you will get what 3, right? As you can see. Now suppose when we will compute the next step, we have to 2 and 1, right? So let's suppose we'll compute 2 and 1, means the remaining is what 3. We have already taken what 1 and 2 we have taken, so it is coming 3. So when we'll take the JOR of 3, we'll get 3, means we will return 3 to the parent. So back in dp02, you will get updated this value as a 3, right? Because if you take the max 3 3, so means so far if you take 1 3, right, 1 and 3, we'll get what 1, so we'll store at 2 at 1, right? So when it 2 at 1, we'll store what 3 here. Understand? Like this we will update, right? Let's suppose when j is 2, means subarray is this one, so we can't do this time, because if we will take j equal to 2, so entire array we will use, so no second part will left, so it is invalid. So till that is why we'll go 0 1 and 2, and k will come 0 1 and 2, right? So we'll not go j beyond 2. Understand? So what was the timeline that we have used? We have taken for the first time dp11, so let's suppose we'll go from here 0 and 2, so we will get the minimum between 1 and 3 after the subarray finding, right? For the first subarray you will get 1, second subarray you will get 3. So what will the minimum will come? 1 will come. So you will update what dp 0 and 2. So dp array you have to update, right? 0 at 2. So you will update 0 is what? This is your 0. What is 2? This is 2. So you will update 1. Okay. For the next time, it is 0, right? So we'll update plus 1. Let's suppose 1 and 2 is what 1, correct? So in this case, if you'll observe 2 and 3 is coming, so if you'll compute this value, you will get what 1. So dp at 1 1 you will update it. Similarly, this time is getting updated dp at 2 and 1. So like that you will get the value, you will update it, and you will update these values, right? So the final step is we have tried the 1, 2 and 3, you have got 1. Another subarray was 1, 2 and 3, you got the 3, means 1 and 3. Now you have to get the minimum of the XOR, max XOR, minimum of the max XOR. The max XOR is 1 here, max XOR is 3 here. Which one is minimum? This one is minimum, so we will update 1 now. So we'll update, we store 0 and 2 as 1, right? So this is our final memo table that you can see here. Okay, so the final table, when I is 0, I is 0 and k is 2, we have got 1. When I is 1, 1, we will get 1. When I is 2 and 1, we'll get 3. So memo table get updated.
Thank you for watching this video. If you found this video helpful, please like, subscribe, and let us know what you want to learn next in the comment below. And thank you for watching this video.